My name is J.L. Gray. I'm the DVCon panel chair this year. And I want to welcome you to the morning panel session, Where Does Design End and Verification Begin? We've got our great set of panelists here. Brian's going to introduce the whole thing. This is by far the best panel you will hear all morning at DVCon. You will be very happy that you came here, because I don't think there's anything else to do, right? So let me introduce Brian real quick. Brian began his career as a designer and transitioned to verification over 15 years ago. A graduate of Boston University, he previously consulted for Nortel Networks, Picturetel, and Teradyne before becoming the director of design methodology at Vitesse Semiconductor. He was an early team member of Cavium Networks and has been verifying their network processor chips for nearly 12 years. Yeah. And with that, I'll turn it over to Brian.
Good morning, everyone. Come on. We can do better than that, right? Good morning, everyone.
Good morning, Brian.
Good morning.
Excellent. Well, you guys are in luck. We've got a veritable panoply of
What's that word?
Celebrities here this morning. So congratulations to all of you for waking up bright and early. First, I'd like to introduce Dr. Pranav Ashar. He is the CTO of Real Intent. He has an MS and a PhD with an emphasis on EDA from UC Berkeley. Pranav has authored about 70 refereed publications with more than 1,000 citations. And he co-authored the book Sequential Logic Synthesis. Was that the one with Dean Koontz? I didn't read it then.
Magnificent or impressive.
He has 35 patents granted and pending, Dr. Pranav Ashar.
Thank you.
We also have Gary Smith. He's previously the managing VP of the Design and Engineering Group and chief analyst of the EDA service at Gartner DataQuest. He was an early evangelist for register transfer level design methodology at LSI. Currently, Gary is the founder and chief analyst for Gary Smith EDA. And most people don't know this, but he is also the owner of Gary Smith House and Gary Smith Car. Gary Smith. The one in the middle there is Oren Ketsa. He is an engineering manager with Intel's SoC design group, involved in DVD technologies and methodology using both dynamic and static methods. He is formerly of Real Intent, Sagantec, and Silicon Design Systems. And most people don't know this, but Oren is an avid pole dancer. They're all getting nervous towards the right. Harry Foster is chief scientist for the Mentor Graphics Design Verification Technology Division. He holds multiple patents in verification and has co-authored 7 books on verification. Harry was the 2006 recipient of the Accelera Technical Excellence Award and was the original creator of the Accelera Open Verification Library Standard. And most people don't know this, but Harry is also the leader of his company biker gang, the Menotaurs.
That's true.
Is that true? I can see you kind of got that.
Dr. John Goodenough is VP of Design Technology and Automation for ARM, where he is responsible for providing their product development and support design workflows. He serves as a board member of SI2 and Accelera. Wow, you must be very busy.
Too busy.
You're too busy. He received a PhD in VLSI design from Sheffield University.
Yay!
And most people don't know this, but I have absolutely nothing funny to say about Dr. Goodenough.
There you go. You need to come drinking in Sheffield.
So our topic today is about the blurring lines between design and verification. Most people know verification schedules are generally the long pole. They're getting too long. And we need designers to take on a larger role in the verification process. Let me start with you, Dr. Ashar. Dr. Ashar. What are we talking about today? Are we saying that the designers need to start doing the verification? Or are we exiting the era of specialization?
I think it's a discussion because design and verification are, in some sense, two sides of the same coin, if you will. And I think this is a discussion in sort of figuring out where that line is and getting the input of the panelists and the input of the audience, and also to maybe to put out there some trends that are happening in the space.
Okay, so in what ways are we saying that designers need to contribute more to the verification process?
So So design and verification is sort of a holistic process, and I think it's in the best interest of this holistic process if there is a bit of separation of concerns. So designers, they clearly have certain goals in terms of meeting the specs, in terms of optimizing the designs and so on. And the less they are distracted, if you will, in terms of the correctness side of things. And also our designers, they focus on their blocks, and they'd like to optimize a lot in the narrow space that they focus on. And the verification engineers, they would have a bigger system level perspective. So the more you can sort of separate these concerns, and the more the process enables that, the more the tools enable that, the better it is for the overall goal of getting a chip that meets your specs out in time. And we can get into more of a discussion on this as the panel progresses.
Well, so tools like what? Our early tools like lint are ones that designers run to sort of get rid of the course level.
So right, okay. So designers can do a number of things. So one of the goals, I guess, a designer should have is to not lead the verification engineer down a rat hole, if you will. So one of the things that a designer should do, or the designers should do, is to articulate what the verification concerns are in the blocks in the systems that they're developing. So designers have a pretty good idea, if you will, of the parts of the design that are sensitive to being buggy or that need more exploration. And a clearer and an executable articulation of that to the verification team is, I think, a great productivity enhancer. And over time, we've been building the infrastructure for this in the form of the assertion-based flows and so on. And the more system level and white box assertions you have, the better for the process. And this whole process has been getting improved, and as a result of the application-oriented verification processes that are coming into play, as Wally Rines also pointed out in the keynote yesterday. And what that does for the whole process is to focus the verification side of things on these separate concerns, and you end up developing a spec. A lot of it is actually implicit. So once you say, I want to check for CDC, there's a lot of the spec for it that is implicit in the RTL, that's implicit in the SDC, and so on. And that basically can be extracted and checked. A lot of it can be checked in the designer's sandbox itself. And it also leads to a better articulation of what the concerns are to the verification engineer. So basically, I would say there are two things that a designer can contribute to the process. One is a clearer articulation of what the concerns are in some executable form, and to do as much of the design hardening using the wide variety of tools that are becoming available to analyze the design at the RT level, pre-simulation, before handing the design over to the verification team. So lint, as was mentioned, and CDC, and the verification of the power management controls, and various things like that, which can be done at the RT level, should be done at the RT level, so that the verification planning and simulation can focus on the parts of the system which really need that kind of effort.
So are the CDC and the X verification tools that you're talking about, some of these static analysis tools, are they getting to the point where it's sort of a push-button operation in the way that lint has become? Maybe Mr. Foster?
Yeah, in fact, that's one thing that has happened in the industry is the emergence of formal techniques. Quite often a user doesn't realize necessarily that they're actually running formal. These applications have emerged focused on clearly defined problems that that are applicable and easy to use. Yeah.
Well, so are we seeing increasing adoption rates of some of these techniques? Because we know that, sort of formal analysis is kind of a complex set of tools that require a lot of hand-holding. And, I feel like that has really overpromised and under-delivered for the last number of years. Mr. Smith, would you agree?
I think the apps, verification apps, which are primarily formal tools, are really pushing it. It was pretty obvious that one of the biggest problems with formal was the complexity of building the models themselves, and engineers just didn't want to spend the time or learn the skills necessary to do that. So it's formal is probably found its home now in the apps area. I think what's interesting, and this is something that sort of across the board that's happening, is that you're seeing designers now starting to use what used to be primarily verification team tools. So there's a crossover now in the tool usage. In fact, formal, in its broader sense, in some of the top teams that I've seen, they're starting to use formal as a design tool, along with simulation or instead of simulation for some of the harder problems.
Well, that's interesting. At Cavium, we sell our chips into a very broad marketplace, and as such, our SoC designs have to be highly configurable. So we've found that formal tools, it's kind of an encumbrance. It makes it more difficult to use formal tools. What kind of what is the sweet spot for formal analysis? Where does it really shine?
Can I take a stab at that?
Sure.
Yeah. So I think basically what is different today from what where verification was maybe 5-10 years ago is that people used to talk about formal and simulation and so on. So at some level, these are technologies. Mm-hmm. And I think what people are doing today is realizing that it's not technologies that we need to sort of think about, it's about solutions. And so we're thinking of solutions for CDC, for X management, for power, for the early functional verification to catch the easy errors and so on. The formal sort of becomes sort of one part of the solution, so it's not the solution, it is a part that contributes. It's a sort of a collection of techniques that you put to enable that solution. And it's sort of under the hood, and a lot of the specification is sort of implicit. So in the 90s, now we're fighting the ABV wars, basically how do you write the assertions and so on. And I think that is a solved problem for a lot of the verification that you need to know in the SoCs today. So an SoC today is a collection of IP that you're going to put together. So let's say you focus on the mobile domain. The reference design across the board for all the companies competing in that space is pretty much the same. They're putting together the same set of components, and they're competing with each other on the integration and execution. And the envelope in terms of verification is being pushed on at the interfaces and not inside the IP. So basically they're looking for verification solutions at the interface level. So formal is to answer your question, is a part of the solutions that people are developing. People are not thinking about formal as such as a solution. It's just becomes implicitly a part of the solution.
So we're saying that we're sort of tricking some of the designers in the verification into using formal techniques without making it quite so difficult as it used to be.
So, I mean, yeah, tricking is sort of, I would say it's an organic process, and it's enabled by the fact that you understand the problem you're trying to solve, so the specification becomes implicit. And over the last 20 years, the analysis techniques, the formal analysis techniques, they really come of age, and the ability to prove properties in models with 10,000 flops and so on through automatic abstraction and through various things, and also I think one of the things that's happening, which is I think not been taken advantage of so far, is that once you start focusing on the solution to a specific a verification concern, it helps in the debug also. So basically, you know that you're solving the CDC problem or the power problem. Then in that situation, even if the formal analysis is incomplete, there is a lot of information that it has already extracted as part of that incomplete analysis that can be put in front of the verification engineer or the designer as something actionable. And once you limit the scope of what that verification is doing, you understand the design idioms that are being checked and so on. I think formal analysis and static analysis, I wouldn't say formal analysis, basically a combination of the structural analysis and formal and the synthesis of all those techniques. It can really take verification to another level. So.
Actually, I think there's another dimension to the problem in that historically, formal has required a lot of sophistication in terms of formal specification, which is non-trivial. Even for experts, it's non-trivial. I mean, certainly you have the issues in terms of managing the state space and all these things you have to do to complete a proof. But what I think the beauty in terms of what's evolved in terms of these automatic applications is that you no longer put the burden on the user to actually come up with the spec. The formal properties essentially are automatically generated.
I actually tend to agree with Brian with your comment about tricking. I mean, you tell the designers that, okay, they want to, you need to run a formal tool. They won't do it. I tell them, okay, here is a tool. It will check your, Pranav talk about CDC or, X propagation for that matter, and you'll run it. You'll get a report, and you need to debug that. That's a much more, well understood task designer will do, and it also goes back to your initial question or comment about these are designer tasks. These are not verification team. I mean, the goal is for the designers to do that on every unit, and they're in the best position actually to do that because they know the design and they can sift through these, thousands of errors, potential errors, and fix them or waive them.
So I would say that we've evolved from a time when I think the discussion was about whether to deploy these kind of techniques to a point where I think we're discussing about how to make them work better. So.
Well, I wanted to ask Dr. Goodenough, you guys have used actual formal analysis, and we'll get back to the static analysis at some point. But you guys have used formal analysis at ARM, is that correct?
Yeah, we've been, I would say formal's been an experiment running for 15 years. And in the last 2 to 3 years, I've started to see it gain traction as the tools have matured. And I think, it's been a technology. Formal's been a technology. It's a solver engine, and it's what are you going to do with that solver engine. And I've seen the practical workflows start to evolve in a number of areas over the last 3+ years, and we've started to clearly segment our use of formal out. And we have a little internal acronym called AHAR, and that's using formal for avoidance, and that's where it crosses over into the design side. And Oren was saying it's absolutely right. The designers, they understand the design, so they can reason about the design in a way a verification engineer can't. And if you can encourage designers to use formal early in the design cycle, in some ways to perhaps replace the little mini TBs that they write to just sort of stimulate and exercise their RTL as they're developing it, or at the same time as doing that, you can encourage them to take actually a more structured approach to design in the first place, and that leads to better structured design that then pops out populated with assertions, and design where the interfaces are much more cleanly documented. And we've actually found some success there with some design communities. Where it's always a problem is where people are bringing legacy along with them. If you've got a clean sheet, it's easy to adopt a new methodology. That is seldom the case for many of our design teams. They're reusing blocks or taking blocks from another design center, which the way they've written and the way they've been structured was with another design. So that avoidance area has been good. I think we talked about using prepackaged flows, and that's the area where we've seen good collaboration, I think, between designers and verification engineers. So we have what we call the using formal as hunting, so that's the H in AHA, where you take a variety of packaged flows which are going to operate on assertions that primarily have been authored by the designers, but you're then giving them a set of packaged flows that need extension. They're not just push button, because the push button only does the 80%, and you can stretch the 80% to 90% by providing a methodology to extend those or to instrument more assertions. I think where jury's still a little bit out is what I would call on the absence. So that the last A is absence, where you're trying to do some end-to-end formal proofs to show something like deadlock or live lock or data corruption is not a possibility. I think we've seen good successes in informing designers about things that they didn't know about their designs by having then formally trained people doing some modeling and some end-to-end verification, and you end up, I think, there with a lot of spec clarifications as opposed to necessarily complete 100% proven assertions. But in all of those areas, I think there's been some significant progress, but there's still a lot to go. But certainly, I would say the static formal engine is finding its application now in those three workflows and methodologies.
And we're increasingly having designers do more of the CDC and the X-checks and the lint